Hi, this is Vivek from Delhi Law Academy, and the kind of problems that we're going to discuss right now are direction problems. Direction problems are very common in the logical reasoning section. You can typically count on 2, 3, even 5 sometimes, depending on the exam that you're writing. But they are an examiner's favorite because not only do they test your direction sense, many times they also end up testing your mathematical skills. And we'll see how in just a moment. Okay, so to solve any problem that involves directions, first one must know what the cardinal directions are. What do we mean by cardinal directions? Cardinal directions are the most fundamental or the basic directions. So the ones that you see on this figure, these are called the cardinal directions. Incidentally, this figure itself is called a compass rose. Rose as in the flower. It's because this diagram resembles a flower vaguely. So this diagram is called a compass rose, and these directions that you see are called the cardinal directions. Now, how do you remember the order of these? There's several ways. The one that I like is to remember the acronym NEWS, news, and then remember the shape. All right. So if you're drawing the compass rose for yourself and you have NEWS like this, the question always is, where should I put east and where should I put west? Is it to the left or the right? If you remember, that's perfect, that's great. If you don't remember, then what you can do is remember this shape, a lightning bolt, right? What is this shape telling you? It's telling you the order in which to use these characters in NEWS. It's telling you that first you put N here, you put E here, you put W here, and then S. And that is your compass rose. The diagram is a bit confusing, but all you have to do is remember news and the lightning bolt. The lightning bolt tells you where to place N, where to place E, and W, and S. So once you have that, you know that north is on the top, east is to the right, west is to the left, south is at the bottom. If you have these things clear, then a few more names that you should know. The direction between south and west is called southwest. Between north and west, northwest. North and east, northeast. South and east, southeast. Fairly obvious. So this direction, once it's clear in your mind, you have one of the basic skills required to solve direction problems, but there are a couple more things that we'll see on the next page. Okay, guys, this page covers a very important concept because there are several questions that are set just on this concept. It tells you the direction of the shadow of a person at different times during the day. Now, once you learn it, it's very obvious, but do pay attention when I'm going through it. Look at this very poorly drawn diagram on the right. The sun is up here. The rays of the sun are hitting this man standing here, and his shadow is in the opposite direction of the sun, right? The important thing to remember is the opposite direction. Shadow is always opposite to the light source's direction. Now that we understand this, let's read the first few points here. At the time of sunrise, if a man stands facing east, his shadow will be towards the west. What does this mean? At sunrise, the sun is actually rising from the east. It's rising from here, right? Sun rises in the east, sets in the west. Sun is rising from here. Let's say the man is standing right in the middle. So what we just saw above, we saw that the shadow's direction is opposite to the sun's direction. So since the sun is rising from the east, so it makes sense that the shadow would be heading west. So that's what the first point is saying, that if at sunrise, if a man stands facing east, his shadow will be to the west. Second point, at the time of sunset, the shadow of an object is always in the east. Second point is exactly opposite of what we just said. At the time of sunset, the sun is now going to the west, right? Sun sets in the west. So sunset, the sun is here. So the shadow is no longer to the west, it is to the east. Just the opposite direction of the sun. So we've covered the first point, we've done the second point. Third one, if a man stands facing north, at the time of the sunrise, his shadow will be towards his left. And at time of sunset, it will be towards his right. How does this make sense? Let's draw a fresh diagram. So this is north, east, west, south. So a man is now facing north, right? So he's standing, let's say he's standing right at the center and he's facing north. During sunrise, the sun is here. The sun is here, So his shadow is to the west. And that, you see, is his left side. That's what the first part is saying. During this time of sunrise, the shadow will be towards his left. During the time of sunset, now the sun is no longer here, the sun is here. Because it's sunset, so the sun is in the west. And again, his shadow is not going to be here anymore, it's going to be in the east. So none of this is any more true. So sun is in the west, shadow is in the east, and now that shadow is to his right side. Right, this is his right side and this is his left side, simply because he is facing north. Right, it's given that he's facing north. Then at the time of sunrise, his shadow will be towards his left, and at the time of sunset, it will be towards his right. That's what we just saw. Brilliant. So the last point, and this one is fairly obvious. At 12 noon, the rays of the sun are vertically downwards, and hence there's no shadow. Now, this is not actually true in India, technically speaking. This is only true at the equator, and that too at a certain time of the year when the sun is actually directly above. But for the purposes of most questions, this is what we assume, that if the question says that, say, Suresh was standing at the crossroads and it was noon, then you have to assume that Suresh actually has no shadow, because at 12 noon, the sun is directly above the person. Directly above. So his shadow is actually directly below him, and it's not in any direction. It's not left, it's not right, it's directly below him. So at 12 noon, there will be no shadow. This was a tough and slightly vague concept, so do take a couple of seconds to make sure you get it thoroughly. Okay, now that we got the shadow concept with the sun at sunrise and sunset, another essential that you will definitely need for solving direction problems is the Pythagoras theorem. The Pythagoras theorem is one of the most fundamental theorems in trigonometry, in geometry, in mathematics. For those of us who have some trouble remembering it, let's just go over it again very quickly. The Pythagoras theorem applies to a right angled triangle. So any right angled triangle, the theorem applies. And what the theorem states is that in a right angled triangle, if one of the sides is A, the other side is B. This is the length of the side, guys. So if one side has length A, the other side has length B, the third side, the longest side, has length C, then the theorem states that A square plus B square is equal to C square. So the sum of the squares of the two sides is equal to the square of the longest side. The longest side is actually called the hypotenuse. So that's literally Pythagoras' theorem's statement. The sum of the squares of the two sides of a right angled triangle is equal to the square of the hypotenuse. How do we use this? We'll actually see, we're going to solve some examples. So we'll actually see how we use this. But for us right now, suffice to know that if we know this side and we know this side, we can always calculate this side, as long as it is a right angled triangle. As long as this angle is 90 degrees, we can calculate. If we know two of the sides, even if we know, for example, if we know C and B, we can calculate A. If we know A and B, we can calculate C. So that's the takeaway for us. Now a shortcut that comes in very handy during exams, save you a lot of time, a concept called a Pythagorean triplet. A Pythagorean triplet is just, it's three numbers that happen to obey this relationship, and they also happen to be whole numbers, right? They're integers, they're whole numbers which obey this relationship. The most common and the examiner's favorite, which you'll see in almost every question, is 3, 4, 5. What does it mean to say that 3, 4, 5 is a Pythagorean triplet? All it means to say is that 3 square plus 4 square is equal to 5 square. How is this true? 3 square is actually 9, 4 square is actually 16, and 9 plus 16 is 25, which is 5 square. So how does this help us? This helps us because we'll see in a question that Ramu walked 3 meters in one direction, took a left turn and walked 4 meters in the other direction. You know immediately that the distance between this point and this point is going to be 5 meters. If he walked 3 meters like this and 4 meters like this distance is immediately going to be 5 meters. You don't have to sit and calculate, you don't have to write this formula. You can immediately write 3, 4, 5. So it's a Pythagorean triplet. The thing about Pythagorean triplets is that even multiples of this also obey the same relationship. So instead of 3, 4, 5, if you had 6, 8 and 10, you'd find the exact same thing holding. So 6 square, which is 36, plus 8 square, which is 64. 36 plus 64 is equal to 100. 100 is 10 square. So 6, 8 and 10 also follow this Pythagorean triplet relationship. So this is something that will save you time in examinations, something that you should definitely keep in mind. Okay, since we have now covered the basics required to solve direction problems, now we're going to look at some example questions. First question, Shiva starting from his house goes 5 kilometers to the east, then he turns to his left, goes 4 kilometers, finally turns to his left again and goes 5 kilometers. How far is he from his house and in what direction? So the way to solve this is to start drawing a diagram so that you can trace Shiva's movement. So let's say this is his starting point, and we know that our directions are as per north, east, west and south, right? So from here, if he's going 5 kilometers to the east, let's assume that up here is north, just as per this direction. So if he's going 5 kilometers to the east, that means he's going in this direction, and this is 5 kilometers. Now he turns to his left. When somebody is going to the east in this direction, and then their left, if they're turning to the left, that means they're heading north, right? Because left is this side, right is this side, left is this side. So when they're turning left, that means they're heading north. So we are told that he turns to his left and he goes 4 kilometers. So this direction he moves, which is north, and he goes 4 kilometers in this direction. Finally, he again turns to his left. So left is here, right is here, again turns to his left and goes 5 kilometers. So he's back here and he's gone 5 kilometers. How far is he from his house and in what direction? This was his house. This is where he is right now. We know this is 5. We know this back again is 5. And we know this was 4. So we know that this is just a rectangle and this side is also 4 kilometers. So the answer is that he is 4 kilometers from his house. And if you were asked the direction, he is actually to the north of his house, because his house is here, he is here right now, and between these two the direction is north. So he's to the north of his house and he's 4 kilometers away. So that is the answer for this question. Okay, so the next question is Suresh starting from his house goes 4 kilometers to the east and then turns to his right, goes 3 kilometers. What minimum distance will be covered by him to come back to his house? So the way to approach this is again start with a diagram. So Suresh is starting from his house. So let's say the house is here, and of course our compass rose is north, east, west and south. So he goes 4 kilometers to the east. So that means he's traveling 4 kilometers in this direction. And then he turns to his right. And we saw earlier that left, right, what it meant. So turning to your right when you're traveling east, that means now you're turning to the south. And he goes 3 kilometers. Guys, recognize these numbers. These numbers are our Pythagorean triplet numbers. You have a 4, you have a 3. The question is asking what minimum distance will be covered by him to come back to his house. So the question is effectively asking, what is this distance? What is this distance? And we already know that in a right triangle, if one side is 4 and one side is 3, then without even thinking we can say that the third side is 5. Why? Because this is a Pythagorean triplet. This is a 3, 4, 5 Pythagorean triplet. So this distance, which is the shortest distance back to Suresh's house, is nothing but 5 kilometers, which is the correct answer. Next question in this video. One morning after sunrise, Juhi, while going to school, met Rohini at Boring Road crossing. Rohini's shadow was exactly to the right of Juhi. If they were face to face, in which direction was Juhi facing? These are your sunrise sunset questions. We are told that it is morning after sunrise. So very simply, the sun is in the east, and any person, any object is all going to have the shadows to the west. All shadows are to the west, right? Because the sun is in the east. So Rohini, Juhi, both of their shadows are going to lie to the west, right? We don't know exactly where they're standing. We don't know who's facing who in what direction, but their shadows are going to be to the west. Now the second sentence, Rohini's shadow was exactly to the right of Juhi. So this shadow is exactly to the right of somebody. So if somebody is facing in a certain direction and the west is to the right, the question is what direction are they facing in? So very simply the answer is that they are facing south. Why? Because if you're facing south, then you're facing like this, and this is your left side, this is your right side, and this happens to be west and this happens to be east if you're facing south. So that's the direction Juhi is facing in, because Rohini's shadow is to the right of her, so she's facing south, and the answer is B. So those are all the questions that we have in this video. Thanks.